Woohoo! We're here with Math 75 and Sharktopus so that we can go over the chapters 9 through 13 practice test. We're going to cover a lot of ground, a lot of different concepts, so I encourage you to make sure you've got something to drink. Isn't that pretty? And maybe a snack or, some music to listen to, and let's get going. So this is going to progress. It does progress from 9 through 13 is the way that I set up this test. So you'll notice that it's going to start with the derivatives and then move its way through the applications and then finally some integrals. Woohoo! Let's get started. So number 1. This is a multiple choice one. These are all multiple choice except for the third problem is actually a matching problem because that was the only way I could figure out how to set it up in Canvas. So number 1, we've got a function. Yay! F of x equals 4x cubed plus 1 over x. And I can already see I should have probably capitalized this. So capital F. Find the instantaneous rate of change of f of x at x equals 1. So instantaneous rate of change. When you hear that, that's just like the secret code word for take the derivative. Yay! So if f of x equals 4x cubed plus 1 over x. Remember, the first thing we're going to want to do is rewrite that in a way that makes it easier to take a derivative. So I'm going to rewrite it as 4x cubed plus x to the negative first power. To take the derivative, I'm going to use the power rule. Woohoo! So 3 comes down in front of, or 4 hangs out. I guess we could do the 3 and the 4 in either order. 3 comes down, and then we subtract 1, so that leaves x squared. Remember, when you're taking a derivative, you get a demotion. The x's all go down 1 power. Then the negative 1 comes down. I've got x, and then I also subtract 1 here, but remember, with negative exponents, when you take the derivative, the number, the absolute value part of it, actually gets bigger. So what does that mean? Well, that means that the first derivative is going to be 12x squared minus, see the plus, the minus 1, x to the negative 2, the negative second power. Oof, that's hard to say. Okay, so is that the whole problem? And the answer is no. What it wants is it wants the instantaneous rate of change of f of x at x equals 1. So we need to find f prime of 1. So I just plug in 1 squared there. And then this is 1 over x squared. So it's going to be 1 over 1 squared. So this is 12 times 1 minus 1 over 1. Which is 12 minus 1, which is 11. Yay! And up here for part A, I see, 11. Yay! We're very excited. Okay, let's look at part B. This is, sorry, it's Sharktopus. There's quite an undertow in the math paper. Okay, part B. Find the equation of the tangent line at x equals 1. Okay, so we're going to be looking for a tangent line. Notice that from A, we see that the first derivative at 1 is 11, and that's the slope. So our slope is 11. We need the point. We need the ordered pair at x equals 1. Now, where do I plug it in? Well, I've already plugged it in f prime, and I got 11. That gave me the slope. Remember, to find the point, I'm going to have to plug in 1 into the original, not the derivative, the original function. So that would be 4 times 1 cubed plus 1 over 1, and that's going to be 4 times 1 plus 1, which is 5. So for this one, my point is going to be, and that's equal to y. Notice that the the function itself gives you y. The derivative gives you the slope. Okay, so I know that my slope is 11 and my point is the 0.15. I'm going to go ahead and use point slope, I think. Y minus 5 equals 11, x minus 1. Y minus 5 equals 11x minus 11. Add 5, add 5. Y equals 11x minus 11 plus 5 minus 6. Hopefully this is one of our options, 11x minus 6. Ooh, look, it's right there. Woohoo, very exciting. So remember again, let me go over, just the instantaneous rate of change is the derivative. Then we plug in 1, and that gives us the instantaneous rate of change of the function. So this is how the function is changing at x equals 1. That gives us, from that value, we got that the slope was 11. We plug 1 into the function to find the y value, because y is equal to f, not f prime, f. And then I've got a point when x is 1, y is 5, and we know the slope is 11, so I can create an equation of a line from that. Okay, woohoo! These are not easy problems. This is the grand finale of this class, so a lot of these problems are going to have multiple parts. But you guys can do it. You're brilliant. You're smart. You're amazing. Just stay hydrated, eat your vegetables, and get lots of rest. Oh no, look at all of this stuff. I mean, seriously, you could scare someone with this. You could hold this up if someone was, you know, kind of annoying you, and you could hold this up and they'd run away. I mean, this is a perfect way. If you're just, you know, if you find that in your life you are surrounded by too many friends, too many people, you're too popular, start doing math. Guaranteed you'll shed some of that popularity right there. Okay, no, that's not true. Everyone loves mathematicians. We are the most popular kids on the block. Okay, I've got a function, s of t, and it is not the most fun function in the world. And the idea was to create a function, I can't take credit for this, the book came up with this one, but I liked it, that is just nasty enough that you don't want to multiply it all the way out. So number 2, the problem is asking you to use the power rule and or the chain rule so that you can differentiate. Remember that d squared s over dt squared is at t equals 1. That's the second derivative. So ds over dt equals, and then I take the derivative. So the derivative of 3t becomes 3. Remember, when you're taking a derivative, you get demoted. The power goes down by 1. Next up, okay, I got a bunch of stuff. I'm going to use the chain rule here. You can also think of it as the power rule in some ways. Chain rule, power rule, your choice. The -4 hangs out, right? The number out in front, the coefficient, just hangs out when you differentiate. The 3 comes down. The inside stays the same. I subtract 1 from the 3. But then the chain rule says, then I take the derivative of what's inside. So that's 2 times 4t to the 4 minus 1 plus 0. Take the derivative of this, the 4 comes down. So I've got 2 times 4, that's going to be 8. I subtract 1, that will be 3. But the derivative of 8 is 0. So let me clean this all up. 3 minus, here I've got a 12. I'm going to go ahead and multiply that out. 2t to the 4th plus 8 squared. This got a demotion of 1. But then inside here, I've got 8t cubed. Now, I've got a couple of options. I think what I'm going to do is I'm going to bring this and that 12 together right now, just so I don't have a lot of stuff hanging out in all sorts of different directions. So I've got this and I've got that. So let's bring those two crazy kids together. 12 times 8 is 96. And notice that I have created a problem in which I can not only check whether you know the chain rule, but now notice that we're going to be dealing with the product rule because it's two separate things. So this is the problem that just never, this is the problem that gives back in spades. Okay, second derivative. First derivative, second derivative. Derivative 3, 0. Now, I'm going to separate the way I'm going to look at these two. I'm going to look at this as being the first part of the product, and this will be the second part of the product. Notice that for the product, I'm also going to be having to use the chain rule. Super fun, right? Okay, so I'm going to take the derivative of this. So the derivative of this is going to be 96 times 3 comes down, t to the 3 minus 1. That's our yellow part, and this one is going to get its derivative taken. And then remember that for when you take the first derivative, you leave the second one unchanged. So this is just that second factor there. Then, now normally it would be a plus, but this is all negative, so minus. Then 96t cubed stays the same. For the second part, I don't change the first one, but I change the second one, right? They take turns. Product rule says take turns. And I know everyone doing this is like, oh my gosh, this is so much. But I did give you a little tiny present, and that is this doesn't involve the quotient rule. So you're welcome. Yay! No quotient rule. Okay, I got to take the derivative of this one, the purple guy. So remember, we go from the outside. The 2 comes down. I get the 2t to the 4th plus 8 to the 2 minus 1. And then I multiply by the derivative inside. That's, well, we know there. It's that one. 4 comes down. 2 times 4 is 8t cubed. And then I take the derivative of 8. That's 0. This is a lot. Shall we simplify and see what the heck's going on? 0, I'm going to drop that. I'm going to go ahead into my calculator, and hopefully you do have a calculator because this one, oh, you can see me calculating things. This one is going to take a lot of calculations. Oops. 96 times 3. Okay, so negative 288 t squared. There we go. Times the quantity 2t to the 4th plus 8 squared. Okay. Minus, I'm going to bring all this together. So 96 times 2, 192 t cubed times 2t to the 4th plus 8 to the 1st power, and then times 8t cubed. Now here's the thing. In this particular problem, you are asked to find the second derivative at t equals 1. So you don't actually have to answer what the algebra looks like. So you don't have to make it look pretty if you don't want to. If you would like to make this look beautiful, go for it. I'm going to go ahead and I'm going to just say at t equals 1, I've got negative 288 times 1 squared times the quantity 2 times 1 to the 4th plus 8 squared minus 192 times 1 cubed, all times 2 times 1 to the 4th plus 8 times 8 times 1 cubed. Oh my goodness, this is a lot. Negative 288 times 1 times 2 times 1 to the 4th is 2 plus 8 is 10 squared. So I've got negative 288 times 10 squared is 28,800. So 28,800. That's that first one. minus, okay, let's take a look at this. This is 192 times 1. Inside here, we already know 2 times 1 to the 4th is 2 times 1, which is 2, plus 8 is 10. 8 times 1 to the 3rd is 8 times 1, so that's 8. Okay, 192 times 10 times 8 equals 15,360. And then I get negative 44,160. Oh my gosh, that's a lot. There's a lot of math hanging out there. So one thing you might ask me is, wait a minute, these are both negative, why did you add? And I'll remind you that two negative numbers, if you're putting them together, if you get negative 28,800 minus 15,360, since they both have minuses, we actually add them together. We add the values with a minus out in front. Okay, let's hope this is available in one of those. It is! Oh my goodness, oh my gracious, we're so happy. How happy are we? I'm pretty happy. Okay, I'm going to go to the next page. Now the next page is a little bit weird. This is the one that I said was matching. Basically, I wanted a single problem with revenue. So if you think back to all that we've done this semester with revenue, we've done a ton of stuff. So what I'm actually asking you to do is to go through and do a lot of different things to this one revenue function. Now, as my gift to you, I have actually figured out what the revenue function is and written it out, so you don't have to construct it. So this is the total revenue function for a hammer. So match each item, A through E, with the corresponding answer. Now, on Canvas, for each one, it will give you a drop-down option you choose for each one. And I will tell you, I haven't double-dipped, so each one of the answers either corresponds to one of A through E, or it doesn't correspond to any. There's no answer that matches more than one, if that makes sense. This one, I've put a stack of paper underneath because this is going to take some work. It's not going to be impossible work. It's just going to be kind of long. So let's work through it. This one is worth 20 points instead of being just worth 10 points like the others. So, part A. If the revenue, this is total revenue, find the marginal revenue function. So as soon as I say marginal, that means derivative. So what is the derivative of r of x? Well, 24x becomes 24. The negative 0.01 just hangs out. The 2 comes down. We subtract 1. We get 24 minus 0.02x, right? Because 2 minus 1 is 1. Okay, and we're supposed to find the marginal revenue function at 100. So that's 24 minus 0.02 times 100, which is 24 minus 2, which is 22. Woohoo! Yay! Okay, we got one down. Next. Oh no. I wrote this and I even regret it. So, part B says, remember when we find the marginal revenue, that is an approximation of the cost of the very next hammer. And so in part B, I'm saying, let's figure out whether this is correct. So if I find R, normal R, look at how there's no derivative there. Normal R of 101 is the cost of all the hammers. 1, 2, 3, 4, 5, 6, all the way up to 101. I'm going to figure that out. Then I'm going to figure out R of 100, and I'm going to subtract them to see how much that last one, that 101st one, cost. So this will be 24 times 101 minus 0.01 times 101 squared. Okay. 24 times 101 minus 0.01 times 101 squared. Isn't it cool the calculator can just handle that? And I get 2321.99. Okay. And then let's figure out what R of 100 is. So that's going to be 24 times 100 minus 0.01 times 100 squared. Okay. I'm writing this down and it's okay because it is a terminating decimal. 24 times 100 minus 0.01 times 100 squared. And that's going to give me 2300 exactly. And so if I subtract the two, let me scooch this up just a little bit. R of 101 minus R of 100 is 2321.99 minus 2300 is equal to 23. Oh, no, it's not. Yay, white tape. $21.99. So this is the revenue from the 101st hammer. So I forgot the dollar sign up there. So this was our guess, our approximation using the derivative. $22. The actual revenue from selling the 101st is $21.99. So how good was our approximation? Oh my gosh, so good. Can I convince you that this was way easier than doing this? Hopefully I can, because this actually was a little bit faster. So, okay, it's a pretty good approximation. Let's go on to part C. You'll notice I'm not trying to do any matching yet. I'm going to do the matching at the very end. Part C. Oh, you can't see this. You can't see this? Ha ha. Okay, I'll read it, but then it has to go away because there's no way to get these both in the screen at the same time. So the sale of how many hammers X will maximize the total revenue in dollars? So in part C, we want to maximize revenue. So you can use a couple of different parts of the class to find this. The first thing is that, let me rewrite this. You can look at this and realize that when we're looking at this equation, this function, this is a parabola opening up downwards. So the maximum will be the vertex. So if you know how to calculate the maximum or the vertex, you're done. The other way to look at this is to say, oh, well, and here I'm going to use the technique that we just studied. If I know the derivative, which I do, it's 24 minus 0.02x. If I set that equal to 0, that will look for this point where the slope of the tangent is 0. So you could either calculate the vertex or look for the slope of the tangent equal to 0. I'm going to do this. I know this is an odd choice. A lot of people are like, just the opposite of B over A and you're done. I know. I just want to show you that this will also work. And the cool thing is right here you can see, now keep in mind R of X was written backwards, so this is A and this is B. In terms of, if you remember the work on parabolas, this is the A, this is the B. And the formula for the vertex is B, the opposite of B, over 2A. There's B, there's the opposite of 2A. So it's exactly the same formula. Okay, I know, mind blown, right? I'm going to calculate this. I know everyone's getting a little bit tired. I know I'm just a little bit out of math right now. Okay, now what are the units? Well, X was given to us as the number of hammers. So this is not dollars. X is 1,200. So we will maximize revenue at X equals 1,200. So if we produce and sell 1,200 hammers, we will be at the top of that curve. We will maximize our revenue. Okay, now let's look at the next question. Oops, that's not the next question. I mean, that is the next question, but where did I put it? There we go. So the next question is part D, find the maximum revenue. Okay, I can do that. So to find the maximum revenue in part D, what I have to do is I have to take the 1,200 hammers and plug them into the original revenue. So we take the 1,200 hammers and plug them into the original revenue function, which would look like this. There are a lot of moving parts to this, and I just want to say, if you're keeping up with this, bravo. This is not simple. We're doing straight up calculus now, and there's a lot of different parts, like what's X and which X do you put into which function, and now this is the regular revenue, not the marginal revenue. How do you choose? So honestly, if you're keeping up with this, even just barely, awesome. Congratulate yourself. Pat yourself on the head. Again, hydrate those lovely, amazing brain cells. There we go. And I guess not directly. Drink the water. Don't just pour water on your head. That won't necessarily help your mathematics. Although it could. I mean, it's worth trying if that's something. You know, we could have the bucket calculus challenge for those of you who are, old. Okay. So let's take a look and plug this in. I've got 24 times 1,200. And then I want to double check. Yes, 1,200 minus 0.01 times 1,200 squared. And I get 14,400. So 14,400. And this is revenue. So in other words, what this is saying is it's saying right there at the top, where the slope equals 0, the coordinate of this point is 1,200, $14,400. Does that make sense? I know I just asked you if it makes sense. You can answer me, but I can't hear it unless I listen very carefully. Hopefully you're saying, yes, it makes total sense. So this is the output equals the number, in this case, it's the number of hammers. And this is the revenue in dollars. Okay. So we've got that. So what in the world could I possibly ask you next? And the answer is, oh no. Find the maximum revenue if production is limited to at most 1,000 hammers. So in other words, we can't make 1,200 hammers. It would be lovely, but we can't actually make that many. So in this case, we've got our beautiful, beautiful revenue function. And we know that this point is 1,200, but we're told we can't make more than X equals 1,000. So we're only allowed to be on this portion of the graph. So which is the biggest point? Well, I would claim That is the highest point. Now, this is this point from part D. Like if we've got all the space in the world, we can make as many hammers as we want to sell, then we should sell here. It turns out, people are, somebody stubbed their thumb making hammers, so we're short, one of the work folks, and so the hammer production is slightly reduced. We can't make 1,200. At most, we could make 1,000. But I still claim that if all we can make is 1,000, then that's still, we should try to make it that many. So I claim 1,000 ends up being our biggest point. Now, how would we know that? Well, we knew that this point was the maximum, it's the vertex. This is the only place where the slope equals 0. So we don't have any other dips or anything. This is either all increasing or all decreasing. And I know from the shape of the parabola, this is going up. So this is the maximum point. I'm going to produce 1,000. Okay, so let's work that out. So that's going to be 24 times 1,000 minus 0.01 times 1,000 squared. Let me clear this. 24 times 1,000 minus 0.01 times 1, 2, 3 squared equals 1,400. Or sorry, 14,000. 14,000, yes. My hand knew what it was, my mouth did not. So 14,000, so we still do pretty well. If we could make any amount of hammers, we'd make 1,200, and then our revenue would be 14,400. However, we can't, so we're just going to make, in terms of revenue, 14,000. Now, do we know what the profit is in this problem? Not at all. We have no idea what the costs are. So we couldn't figure out maybe it could be that this maximizes profit. We'd never know. It could be another point altogether maximizes profit. We don't know enough about the costs. So, are you ready to answer the problem? So the way the problem's going to be on Canvas, I can't do on paper because they're drop-down menus. But I believe what you do is for A, for example, you would pick which of these numbers fit. I've kind of done it a little bit differently. I've written all the possible answers. We'll figure out which letter goes to which one. So, part A was $22. So this, I'm going to put an A next to 22. So for A, you're going to drop down to 22. Okay, B is, I didn't put a box around it, but it was $21.99. Remember, that was the actual cost of the 101st. So that's $21.99 with a dollar sign, and so that one's B. Okay, the sale of how many hammers X will maximize the total revenue. Okay, that was this last one. We've just been talking about it, so I'm going to put a box around it. You probably even have it memorized. That's 1,200. Now, this is not dollars. This is hammers. So that's a hint. You want to look for a number that doesn't have a dollar sign. Okay. And then we need D. Find the maximum revenue. The maximum revenue was 14,400. So that is number D, goes there. And then find the maximum revenue if production is limited to at most 1,000. We said, well, let's make the 1,000. And then we end up with $14,000 in revenue. And so that is there. And all these other ones, these other numbers, those are just red herrings. Those were I put in as extra ones in case people are just guessing to make it a little bit more challenging. Okay, I'm very excited. Are you guys very excited? Why am I very excited? Because underneath all of these pages, oh my goodness, oh my gracious, one more problem. Oh, I can taste it. Ooh. A store finds that its sales revenue, so again, revenue, I really liked revenue for this one, that its sales revenue changes at a rate given by S prime of t is radical t plus t dollars per day, where T is the number of days after an advertising campaign ends. So in other words, they're running some ads and they're going to see how their sales revenue change. The idea would be if you were going to make an ad for something, you'd want your sales to go up. If your sales don't go up, then you've just spent money on an ad and you're not sure why. So this is the calculations to see what's going on. So where T is the number of days after an advertising campaign ends, and T is between 0 and 20. So for whatever reason, this equation no longer holds after about 3 weeks. I guess the ad gets forgotten. Short attention span. Find the total sales for the first 2 weeks after the campaign ends. So you got a couple things going for you. This covers chapters 9 through 13. This is the last problem. This is probably the integral. So you can just use the process of elimination to say this is going to be integration. But also, if you're given the rate, remember that the antiderivative gives you the total. Because the derivative, where's my piece of paper? I keep threatening to make an Elton John puppet, and I haven't yet. So this is the total, and this is the rate. If you want to get from the total to the rate, take the derivative. If you want to get back from the rate to the total, take the antiderivative. This is the circle of calculus life. And let's be honest, what else is there in life but calculus? So this is basically the circle of life. Okay, so if I have the rate and I want to get to the total, I use the antiderivative. Specifically in this case, we're going to use, it says find the total sales for the first 2 weeks. Notice that I've given you a lot of information. You're not going to use it all. I want you just to go from 0 to 14. So you're going to say, well, what is 20 good for? We're not going to use it. We know that this is true up to 20, but we're only going to use it for the first 2 weeks. So how do we do this? We take the antiderivative. So I'm going to set up that integral sign. I'm going to go from 0 to 14 because T is in the number of days. T is the number of days. I'm going to put in my radical T plus T. And then remember I write dt there. That's my, basically it just tells me that is my variable of integration. And does it have a use? Absolutely. Those of you who've taken more calculus, you will know that this actually has a physical meaning. It's the width of these little tiny chunks that you're adding up. But for us in this class, it's just telling us, okay, we're gonna anti-differentiate with respect to T. So to make it a little easier, I'm gonna write this as T to the 1/2 plus T dt. Then I'm gonna anti-differentiate. I'm gonna take the integral. Remember here, to take the integral here, I'm going to add 1. And then I have to divide by that. And then T was already T to the first. I'm going to add 1 and divide by that. So this is the power rule. Now, you'll recall that normally when we're taking the antiderivative, we do plus C. But remember when we're doing a definite integral, then we don't use the plus C. We don't have to. You can, if you'd really like to, go ahead and put it in. I used to put it in and then it ends up canceling out. So it's up to you. I'm going to take this whole thing between 0 and 14. So let me make this pretty as it will get. So I happen to know that 1/2 plus 1 is 3/2. So it's T to the 3/2 over 3/2 plus T squared over 2 from 0 to 14. Okay, we can do this. So this is going to be 14 to the 3/2 all over 3/2 plus 14 squared over 2 minus 0 to the 3/2 over 3/2 plus 0 squared over 2. This is just going to be 0. Remember, a 3 over 2 in the denominator flips up upside down, so we get 2/3 times 14 to the 3/2, which I'd be worried about, except it says, oh, I didn't write. It will say round to the nearest cent. Let's just pretend it already said that. We're going to round to the nearest cent. You'll see that these are rounded numbers. So I'm not going to have to work out anything like bare math or anything. I just calculate this on my calculator. This is going to be 14 squared over 2. And I'm just going to do the whole thing there. Okay, so I've got 2. Whoops, sorry about that. 2 divided by 3. You know what? I'm not sure about my calculator, so I'm going to put my 2 divided by 3 in a parentheses just to make sure nothing gets sucked under, times 14, and I'm going to raise it to the 3 divided by 2. Do you see me doing that? Now, could you write it as 1.5? Absolutely, if you want to do that. I'm going to add 14 squared divided by 2. Now, if you're very careful, you can do all of this at once. We're going to cross our fingers that I haven't left out any parentheses or anything. And I get 132.92213 and some other stuff. Now, remember, this is in dollar. Oh, you can't see. This is in dollars per day, right? Dollars per day. So if we take the total, this is going to be the total dollars, and we're supposed to round. So I get 132.9, and then I look here and I see 2 2's, so it's going to be 0.92. So let's see, is 13292? It is. It's right there. You guys are amazing and awesome. If you have any questions, please let me know. Let the tutors know. I'm happy to try to explain anything, but congratulations. I think this is possibly my longest video ever. So thank you for sticking it out. Go get some hydration. Remember to go outside, look at something green. Get away from the screen so that you don't make your eyes all goofy. And, get out, get some exercise, get some rest, pet a dog, smell a flower, all those fun things. Know that you're awesome, and math on.